All right, hey people watching this video, we got partway through and then I realized I forgot to record. So this is 8-4 trigonometry. We're doing SOHCAHTOA stuff. And the thing that we wrote down up at the top here is that this is for right triangles only. So SOHCAHTOA is the acronym that we use for sine, cosine, and tangent, and it tells you which sides you are using. So sine is opposite hypotenuse, cosine is adjacent hypotenuse, tangent is opposite adjacent. Okay, so example 1 we started doing, and we are doing, ABC was doing sine, cosine, and tangent of angle P, which is this one down here. Now we're doing sine, cosine, and tangent of angle Q. Okay, angle Q, the side that's opposite him is 8. The side that's adjacent, which means right next to his angle, is side 15, and then the hypotenuse side is 17. So now we're going to do our trig ratios that have to do with those three sides. So sine. Sine is opposite hypotenuse. And if we're looking at angle Q, which side is opposite angle Q? Like what's opposite over hypotenuse for angle Q? 8 over 17. And 8 over 17, they want it as a fraction and as a decimal. So 8 over 17 is 0.47. Oh, we've seen that before. Cosine is adjacent hypotenuse. Okay, adjacent is 15, hypotenuse is 17, so this one is 15 over 17. And this one is 0.88. Okay, now hold up. Taking a look at those two, do you see a trend here? These two match. Sine of P is exactly the same thing as cosine of Q, right? And vice versa. Cosine of P is the same thing as sine of Q. That is not a coincidence. That's the way it is always, right? Because all we did going from Q to P is we switched our adjacent and opposite sides. Those guys switch places with each other. So cosine of one angle is going to be the same as sine of the other angle, etc., right? Okay, let's see what tangent does. So tangent, if we do that one, opposite adjacent, what you got? 8 over 15. So it just takes this one and it flips it around, right? And that one is, I think this morning we got 5.3 repeating.
8 divided by 15. Yeah.
Did you get 0.53? Oh, gotcha. Yep. So 0.53. 8 divided by 15. Good? All right, now, example 2. Use a special right triangle to express the tangent of 30 degrees as a fraction and as a decimal. So here's my 30, 60, 90 triangle. We're gonna label him. Which one is the 30-degree angle, by the way? If I label this, if you had to guess. Which one's 30? The top one, right? The smaller one. 30 degrees. This one's going to be 60 degrees. Okay, now, what are the sides of a 30, 60, 90? 1, 2, square root of 3. Which one's 1? The bottom. Which one's 2? Hypotenuse is 2. Yep. Square root of 3 is this one. Okay, that's the way that it works. Okay, so they're wanting us to find tangent of 30 degrees. Tangent of 30 degrees. Here we go. So here's my 30-degree angle. And tangent is opposite and adjacent. Which side is the opposite side? 1. Opposite is the 1. Which one's the adjacent side? The square root of 3. So we have opposite is 1. Adjacent is the square root of 3. No problem. 1 over the square root of 3. Rationalizing, if you need to write that down. Rationalize. Rationalize. Okay, and we want to get that square root at the bottom. So we multiply by what? Square root of 3, right? Square root of 3 and square root of 3. Okay, what is 1 times the square root of 3? Just the square root of 3. What's the square root of 3 times the square root of 3?
3.
Just 3, right? So we have that going on. That is what cosine of 30 degrees is. Now, let's figure out what that is as a decimal. So the square root of 3 divided by 3 as a decimal is like 0.77, I think, or something. I don't remember. 87. I don't remember.
0.5773.
Oh, 0.577. 0.577. Okay, 0.577 or 0.58. I guess we should go 2 decimal places. Anyway, 0.577. Yeah? Now, one more thing. Do you guys all have calculators?
Yeah.
You want to grab them real quick? Because I want to make sure that your calculators are in the right setting. Because sometimes your calculators won't be in the right setting.
Yeah, because I was quarantined during this and I was trying to hold it up to the screen and like have it.
Yeah. So your calculator, and there's absolutely nothing you're doing wrong. You could possibly get the wrong answer because your calculator's in the wrong setting. you want to be in degrees because we're dealing with degrees here, 30 degrees. But there's another setting that it could be under, which is called radians. Radian is another form. It's kind of like inches to centimeters, those conversions, okay? So we use this triangle to figure out that tangent of 30 degrees was 0.577. Type tangent 30 into your calculator and see what you get. You should get 0.577, right? Tangent 30 should be 0.577. Yeah? Yeah. Did anybody not get 0.577? Because your calculator could be in radians. No. Okay, you're good? All right, so we used a special right triangle to get that. You can type that into your calculator. The only thing that I like about using the triangle rather than using the calculator is the calculator is going to round it off. Which answer is better out of these two? This one or this one? Which one's the better one? The top one, because it's not rounded. 0.577 we rounded off, right? But square root of 3 over 3 is the exact number, right? Before we've rounded, okay? So that's the only benefit of doing this triangle method is because we don't have a rounded number. Okay, now, why do we even use the sine, cosine, and tangent stuff? It is for things like this. This is what you will see on the ACT. They will give you problems like this. I'm going to redraw this thing because you can't really see what's going on in the picture. This guy is hiking, okay? And straight across horizontally, like this is like into the hill here. It's 100 feet across, okay? We are trying to find what the incline is straight up and what the walking path is going on here, right? Because he's not going to walk through the hill. This 100 feet is through the hill, like straight into the hill, right? He's going to go up this path, and we want to try to find what that distance is, okay? We know that it's a 5-degree elevation, like just 5 degrees is what it is, which is not a very big amount. 5-degree elevation, we're trying to find X and we're trying to find Y. Okay, we cannot solve them both at the same time, so we have to decide which one we're going to do first. What would you like to do first? X, sure. Okay, so we'll solve for X first. Now, here's the deal. Up above here, we did sine, cosine, and tangent. We did all 3 of them. Here we get to choose. When we're solving for a side, we get to choose which one we're going to use, okay? But we don't just get to choose. We have to choose the correct one, right? Okay? So always look at the angle first. The angle that we have given is 5 degrees, okay? This is a 90-degree angle, so technically we could find that this is an 85-degree angle, but we don't have to have that. We can use the 5-degree angle, okay? So 5 degrees is that one. And then the other piece of information it gives me is 100. And 100 is like a side of my triangle. And which side is it in relationship to the 5? What is that? This one is the adjacent. So label him as the adjacent. If we're solving for X, what is X in relationship to that 5? That's opposite. So we have to choose the trig function that's going to involve opposite and adjacent. That is going to be tangent. Tangent, okay? Tangent. And when we do a trig function, we always put the angle inside of the tangent. So we're doing tangent of 5 degrees, or tangent of 5 is equal to, and then we put our opposite over our adjacent, right? Which one's the opposite one? X, and the adjacent one is 100. Okay, now, last thing before we type this all in is that if we're trying to solve for X, if I try to get this X by itself, how can I bump the 100 to the other side? I'm going to multiply the 100, right? Right now it's dividing, so we're going to multiply. So on your calculator, you could type this in all at one shot. Type in 100 times tangent of 5. And we're going to figure out what the raise is. It's like, I think it's like 8.75 or something. 8.75 feet is the elevation that we have going on there. So just from here to here is 8.75 feet. Not a whole lot, but then again, my angle is only 5-degree angle, so that's not too bad. Okay, now we're going to do the same thing again, but we're going to solve for Y instead this time. So I'm going to use a different color. We're still going to be looking at 5 degrees. Now, we technically know this is 8.75 over here, but I want to avoid using the 8.75 and I want to use the 100 instead because 8.75 was rounded, right? So technically we could use 8.75, but I don't want to use it because it's rounded. So I'm going to use the 100, which is still the adjacent side. And then what is Y? The hypotenuse. So we want the adjacent and hypotenuse. So which trig function are you going to use now? Cosine this time instead. Okay, and we do cosine of what? 5. Cosine of 5 equals, and it goes adjacent over hypotenuse. 100 over Y. Ooh. This one is a little tricky because the y is now on the bottom.
So you
How do we do this?
I don't know. Oh, but then so is it just 100 divided by cosine 5?
Yeah, that's what it will be. Okay, so watch. To get the y out, we would multiply by y. Don't write this down yet. To get the y out, we multiply by y. So it's now over on this side, right? So now I have y times cosine of 5 equals 100. And I want to divide by cosine of 5 to get it over to the other side, right? Divide by cosine of 5. So I end up with y being equal to 100 over cosine 5. Now, I'm going to show you a shortcut. 100 divided by cosine of 5. I'm going to get rid of all this stuff, and I'm going to show you where the shortcut comes into play. Some of you guys might have seen this, like Mr. Muth calls it like a triangle method, right? So if what I'm solving for is on the bottom here, what can you do? Just switch places with those. It's kind of like that triangle method, like force equals mass times acceleration. You can do mass is equal to force divided by acceleration, that type of thing. So if I'm solving for y on the bottom there, I get to swap places with those two and it makes it really nice. 100 divided by cosine 5. Try plugging that in and see what you get for y. Y equals, it should be like 100 point something.
It's 100.3.
100.4 feet. 100.4 feet. So just slightly more than 100 feet, right? Okay, is how much he's walking. So not too much, right? Not too much more. Does that make sense? So when the y is on the bottom or what you're solving for is on the bottom, just switch places with the other one. Okay, good? All right, now on the back side, there's a back side, and it only has one more thing that we're doing. And over here we were finding sides. So like here, we were finding sides. Like sides of my triangles, like we were solving for x and y. This is what we use to find sides of a triangle, okay? There's a little bit difference on the back side, like for example 4, because we are finding angles. So find angles, okay? And there's one little difference that we do. Here we are being asked to find the measure of angle A. Find the measure of angle A. And we're using a calculator to do it, which is fine. That's what we did to find x and y. Here is where angle A is, and we don't know angle A, so let's give it a name. Let's call it like x, right? We can call it x. You could leave it as A if you wanted to, but we're going to solve for x, okay? And we still use a trig function to do this, okay? But we need to know which trig function. So we have 18 and we have 27. What's 18 in relationship to my angle x? Opposite. What about 27? Hypotenuse. So we need opposite hypotenuse. Which trig function is that? Sine. Okay, so we're doing sine of, and always when we're doing a trig function, we put inside what the angle is. But this time we don't know the angle, so we call it x. So we're going to put x in that spot, equals, and then we still do opposite over hypotenuse. Here we have 18 over 27. So do you see the difference? Now we have the variable, the thing that's missing is the angle, and over here we have two things over there, which is fine, okay? Now, technically 18 and 27 would reduce, but you don't have to reduce it if you don't want to. You can. You can call that 2/3, right? Because they both would divide by 9, but you don't have to. You don't have to reduce it at all if you don't want to, okay? Now, the question is, how do I get x out of there? I had a lot of people say you can divide sine over. Don't write this down because it's wrong. You can divide sine over, but x is trapped inside of the sine. It's not like you're multiplying those two. X is trapped inside of the sine, so we can't just do that. How do you get rid of sine? You probably don't know this. It's fine. You do shift. You hit the shift key on your calculator, and it does inverse sine. It inverts it, which undoes it, right? To invert something, it means to undo it. So sine inverse crosses it off, and x is equal to inverse sine of 18 over 27. All right, that's what he looks like. Okay, so you're just going to hit the second key, and you're going to type in your fraction. Okay, and you get what? 41.81. We'll go 41.8 because they want to the nearest tenth, which is 1 decimal place. Okay, so 41.8 degrees. So all you're doing when you're solving for an angle is you have to hit that shift key first. Make sense? When you're solving for a side, you do not need to do that. Okay, but inverse has to do with finding angles. Okay.
I didn't do that way. Can we just... Oh, I probably need parentheses.
Maybe. Yep, there, that's fine. Yep, I bet you have to do parentheses. Otherwise, it's only going to take sine of the first number. Yeah, that's weird. Some people's calculators opens up the parentheses for them, but yours maybe doesn't. All right, last one, example 5. It says solve the right triangle. When it says solve, it means find everything, which is kind of unfortunate. So we have 3 angles. They are named angle X, angle Y, and angle Z, and they want us to find all of them. We know one of them. That's exciting. Which one do we know? We know Z, and we know Z is 90 degrees. Okay, now we have to have names for the other ones. Do you know what we call them? Like side XZ, rather than calling it side XZ, do you know what we call it? So when we're naming angles, we name them with capital letters. When we're naming sides, we name them with lowercase letters. Okay, so we have side little x, side little y, and side little z. Okay, and I'll show you which one's which. Side little x, side little y, side little z. Over here in our triangle, this 5 that's on the left side, do you think that's little x, little y, or little z?
Which one?
The 5. Nobody said the right answer.
Does it go in like a Y?
It's little y. Do you know why it's little y? Because it goes the opposite. It's the opposite of the angle, right? It's opening to that side, right? Yeah, that's weird. Okay, so 9 would then be
X.
little x, right? So z is the one we don't know, right over here, right? Okay, little x, little y, little z. So there's that. Okay. All right, so we're solving for everything that we don't know. We know little x is 9. We know little y is 5. So we know those things. So we need to find the other 3 things. Okay, now, z. Let's talk about z for just a second. What can we do to find z? Yeah, we can technically use the Pythagorean theorem. We can do that. That's fine, right? We can do that. So let's do the Pythagorean theorem. Sure. 5 squared plus 9 squared has to be equal to z squared. 25 plus 81 equals z squared. And then we have, I think that's 106 is z squared. And then we take the square root. And it's going to be like 10 point something. 10.3 is what z is, little z. So we have little z is 10.3. Little z is 10.3. There we go. We already have one thing done. Boom. All right, then we have to find an angle. We only have to find angle x and angle y, and then we're done, right? Which one would you like to find first? X. Sure. Okay, we need to find x. And to do that, we have to use a trig function. There's no option, right? We have to use a trig function, and we have to use 2 of our sides. Which 2 sides do you want to use?
X and Y.
So we technically know x, y, and z. We know all 3 of them, but which 2 are you going to use? Why? Why not z?
Because they're not rounded.
They're not rounded, right? So aside from the fact that they're like easier numbers than 10.3, 10.3 is technically rounded, so it's a little bit inaccurate, right? Like, so we want to use the number that they've given to us. So 5 and 9 is what we're going to use instead, okay? So in relationship to x, what is 9? Opposite. What about 5? Adjacent. So we want opposite adjacent, which is tangent, okay? And we're going to do tangent of what? What goes inside the tangent? X, because we don't know it. Equals, does it go 9 over 5 or 5 over 9? Opposite over adjacent. 9 over 5, right? How do I get the x out of there? I do the inverse tangent, right? The shift tangent. I was about ready to write shift. Inverse tangent. So x is inverse tangent of 9 over 5, and that will give me the angle. And we're going to do to the nearest tenth, one decimal place. 60.9. Perfect. Okay. So I'm going to put 60.9 up here. And that was angle x. Now,
Can we just subtract now?
we could do the same process again and use a different trig function to find angle y, but that would be silly because all of these have to add up to be 180. So we can just subtract from 180, right? And I think it's like 29.1. Now, we can subtract from 180, or another thing that we know is that these 2 have to add up to be 90, right? So rather than subtracting from 180, just subtract those from 90, right? And find the last one, okay? So there's that. On the homework assignment for those people who are watching this video, it's odds on both sides, okay? Tomorrow would be mid-chapter quiz time, but we're not going to do a mid-chapter quiz. We're going to work whiteboards on this stuff so far. So there's that. And then we'll probably mid-chapter quiz on Monday, okay? There you go. Goodbye, people in the video.